Hello, hello, good morning, good afternoon. Yeah, everything is fine. We are live and I'm not on mute. Fine, at least for a while. Yeah, you know my issues with on mute or not being on mute, but never mind. Okay, let's get back to work. After a week, last week I stopped the job of, let's say, a draft routing of the red lines, of the red nets between the MPU and the DDR3L, and it was a result of my, let's say, design work when I tried to find the optimal angular position between the MPU and DDR3L module, and then I finally started, let's say, switching or swapping lines inside of the, inside of the 8-bit word. I found that we can swap the signals inside of the upper byte and lower byte freely. When I am done, I will use the STM32 MX Cube or Cube MX, I don't know how the app is called. There is the signal validator. So I will enter both the MPU ports and the DDR3 ports in the meaning of the signals, nets, lines, memory lines, and then we will see if it works. If not, I will correct the interconnection, but I think it should work, but we will see. So I will continue with the draft routing. This is not the final routing. Obviously, I mean these lines. Yeah, these awful lines with different length, and yeah, this is working state. I only want to find the situation or the state when the PCB can be routed, and then I will find the most difficult track to route, which will be the reference route, and all the others will be length tuned to this, the most difficult to route track. So let's continue. I'm back after a week without any intermezzo in between. A few minutes ago, I was working on another PCB layout, so I'm still in the KiCad, but not in this project. So my brain needs to switch to another project, but yeah, I will get used to. I should have already get used to. Okay, comments. No comment yet. Obviously, we are like 4 minutes in the show, and yeah, let's get back to work. So I will start with this one, with the first red line, and I will mimic the draft routing from the last week. So the second one is here. And obviously we need to connect it here. So it means that DQ12 must be swapped with DQ15 because, yeah, obviously. So 12 to 15, let's do that. 12 to 15. Yeah, just select both labels in the schematic, and there is the vertical mirroring like Z key, Z key, and the signals are mirrored. I always quickly save the project because every application, every program can crash, and we want to avoid this. Yeah, we can't avoid crashing. The KiCad can crash, but I want to avoid redoing some part of the job that hasn't been saved or haven't been saved. And then update the PCB from schematics because we need to update the project from the schematic. Next time, for the next net, I will show you. No, I won't. Yeah, I want to say that there is another option how to change the interconnection of the, change the circuit basically. It's called back annotation. We can make the change in the schematic, and then we can back annotate the change in the PCB, and then we can back annotate the schematic from the PCB. But in my opinion, it's really dangerous because you don't know what you are doing. You can't see all the consequences. Yeah, we can try, but yeah, it's something that maybe some engineers do, some engineers use, but I don't know why. Yeah, I said why, because it's too shady. Yeah, and I hate shady changes. This one must be DQ11, and it's DQ. No, it's not DQM. DQM must be kept because DQM is, what is this? DQM is signal validity. Okay, signal validity or memory word validity. So it must be, I think it must be kept as is. Is it correct? Let's make a quick check. Okay. Yeah, there is the verificator, and we can remap the address bus. That's what the verificator is for. And we can easily swap the bits inside of each byte, lower byte and upper byte. It means we can't, for instance, swap data 0 to data 10 because there are two validity, like the valid signals, the data valid signals, and if we mixed the signals from the upper to lower byte, it means that the data valid signals would be useless because obviously, yeah, if you mix the upper and lower bits, the data valid of the upper and lower byte wouldn't have any meaning, would be useless. Okay, so we need to connect the DQM here. I think we do have a chance to do that. We can do this. As we said, like last week or the week before, we prefer to fan out all the pads from this quadrant. The via is facing the upper left corner, but in some special cases, we can help ourselves with changing the position of that via. Yeah, we can still do that. We can still do this. And I think it's a good compromise, yeah. It's not perfectly, as you can see, the track is not perfectly straight. There is a corner, but I think it's a good compromise. The via is facing the upper left corner and the data track is here, and it can work for us. Plus it's a draft routing, but frankly, I think this part of the track will stay the same because yeah, I can see the issues because I won't be able to route to DQ11. So still there will be, yeah, what I've done in the recent 2 minutes was useless because let's try this. Okay. It was useless because I still need to route the DQ11. Yeah. So this is a DQ14, and we need to be DQ11. Yeah, this is why I played with the via. It's a draft connection, so I will keep it, but 14 to 11. 14, 11. Yeah, I spoke about the back annotation a few minutes ago. We'll see next time. Oh, DQS, it's a pair signal, I think. Let's check it quickly. Yeah, DQS1 is. Hi, Kevin. Thank you. Thank you. Yeah, that's me. How are you? DQS is a pair. So we tweaked the differential pair parameters last week to make the interconnection possible. And now yeah, I think this can work because we have to swap the pairs inside, the signals inside of the pair because they are mirrored. And I think there's still a lot of space. We will see. We will see. So 15. It's a draft routing, so I can place the lines next to each other. Because these two vias. Let's say the signals going through these two vias will not change the reference plane. The reference plane will be still in one layer. So the first layer below the top layer, we don't need the reference plane stitching, not stitching vias, the reference plane vias, like the vias that serves as a return path for the signals. We don't need it, so I can route this signal next to the via closely. Here is the DQM, so there will be a via, maybe somewhere here or here, and this is, oh, I can see that all the signals here, all the pads here are already connected. Okay, so this signal won't go to the left side, but already to the right side. And because there is the curve, the corner, we should steer the signal now to the left hand. If you are, imagine you are going through the track to the left, so this signal must go to DQ8, DQ15, DQ8, 15.8, 15.8, F8. Nice. DQ8. Yeah. We need two vias here, like this. Yeah, maybe slightly different way, but very similarly. And this way, this signal must go here to DQ10. So 8 to 10. 8 and 10. Nice. Okay. What else? DQ9. Oh, one more is here, so I made a mistake. Yeah, I overlooked the DQ9, so let's get back a few steps. So it means that 15 will be Q, will be 9, 59. Never mind, we can always correct our mistakes. It's not a mistake, it's a small mishap. Is mishap a word? Yeah, this. DQM will be connected through the via, like here. And we can continue. What we need to correct is DQ9, which will be swapped with DQ8 or vice versa. So 8 and 9. Nice. Now this signal is our DQ9. Okay, what else? Here is DQ10. Okay, it's a data signal. I think we still need to connect one control signal, but I don't know. I'm not sure. Maybe not. So this one will be DQ. 11, and we must swap 10 and 11. So 10, 11, swap F8 to update PCB from schematic, and nice. And the last one of the red group, of course, we are not finished yet, but last one of the red group is this DQ11. Okay, so it seems that we have connected all the red signals. It means all the data bus signals. Obviously, you can see that this horseshoe shape is or makes the tracks much longer. I can use, for instance, one of the longest, like this one, and we can call the feature to analyzing the track length, which is under the 7 hotkey 7, or here route here, tune length of a single track. Yeah, we don't want to tune length the track, but if you call it, it will show you the current length of the signal. Another way is to view a net inspector here. Here is a panel below, and if I click and select the entire net, which is DQ1 here, I can scroll to DQ1 and you can see 30.3751. So if you remember, I think it's the same number. If I call the net inspector, or the tune length, I don't know how to call it, tune length tool, not length tune, not tune length, length tune tool, 30.3751 is the same. So we will use this net inspector, I think later, but right now I'm going to hide it because it consumes too much area of our screen, and we need as much screen area as possible. So we connected all the red signals, all the data buses, all the data bus signals, and now the red ones, the blue ones. And the blue ones, as we here, as we have a small, I'll move it here. Yeah. Blue signals on inner 2, green on top. Plus, we will use the inner 2 for this pair and for the QM1, because we have to switch the layers because of the signal crossing or net crossing, as well as this, and maybe much more for the other signals, because we have a bunch of blue signals, which scares me a little bit. Yeah. Recapitulation: in 2 weeks, I successfully draft route these signals, which is 16 plus 6 is 22, and now we have to connect all the blue ones, which is 16 plus 7 plus 4, 16 plus 11, 27, so even more than we do. And the plus is that we can rearrange the address buses, as you can see here, including the CASN, RASN, and WEN. Which is probably write enable negative, column access signal and row access signal. I think it's what the abbreviation means. Chip select, obviously, BA, I don't know, and address buses. We will see. So again, we can remap all the signals, including some of the control signals. The remapping happens on the MPU package here, yeah, on the MPU. So it means you can see here that column access signal is to 826, row access signal to 14, write enable to 13, etc. So I think because most likely, because there is a lot of crossings, we will need to swap the signals. I'm going to open the app. I'm going to open this DDR validator or configurator. I don't know how to call it. Maybe DDR control 5 configuration. Yeah. So let's call it STM32MP215F. That's what we need. And before it opens, I have to, yeah, it's already open, but I have to take a mini break because my coffee wants out. Okay, I'm back. I'm not on mute, which is a fortunate event. Okay, so let's access the validator. We always have to go through the component. Oh, updates again. Last week it failed. And yeah, I should have started before the break, but we'll see. 5, 4, 3, 2, 1. Bye. Okay, STM32MP215F. Fan 3, I think. I don't remember. Fan 3, yes. This is our part. This one, start project formally. I don't know, maybe. So it takes a while, a few seconds. Yeah, here is the, yeah, as you know it, CubeMX. And I want DDR3, DDR control 5. Yes. So we have to rearrange the pane a little. And we need to configure the configurator first. DDR3 is our case, 16 bits, and density is, I think, 4 gigabits, 4 gigabits, but I have to check it because yeah, I clearly remember I looked for the answer last week, but I lost my mind. We have 512 megabytes, which is 4,000 gigabits. Okay, 4 gigabits. That's our density. And now here are the here is the configuration, and I don't know. Yeah, here is the validator. Here is the check. Okay, and now I don't know what is our situation. So we need to check it. So C key E is A0. Well, A0 to A7 are signals that can't be configured, can't be swapped. It comes from this application node, I think from here. And you can see here, AC pin mapping by device versus protocol, internal signal swap. I don't know how it works, but I followed this CL default or recommended interconnection. Maybe it will make some issues with routing, but I will not change it. Here are the secondary signals like address only buses or address controls. Yeah, AC signals which can be swapped. It comes from this document that opened in a different window. We can make a quick check. Yeah, and this comes from the table configuration of the interconnection or memory mapping, or what was called, how it was called. Yeah, here are some things I completely don't understand what they are talking about here. Table 7 is listing the default SWISL mapping for each supported DDR3 protocol. Default SWISL mapping. Pardon my language, I don't know what the SWISL means. SWISL is a mixed alcoholic drink. Okay, so let's say like a stir or yeah, mixture, I don't know. SWISL mapping for each supported DDR3 protocol. Default SWISL. As I said, because this configurator offers me only to change A8 to A31, I won't change the A0 to A7. So here are our signals, yeah, all of them. This is funny is that this pinout from the application node is different from the reference design, and it leads me to an idea to verify if no, it's nonsense, because the reference design uses DDR4 and we have DDR3L. So what I'm going to do now is I will set the configurator to our default setup, and then we will swap in the KiCad and in the configurator as well. And before the draft route will be done, I will validate the interconnection. So here, A8 is A0. So A8 is A0. Here, the signals on the left are on the MPU, and here are signals on the memory, probably. Fine. A9 is A7. A9 is A7, that's valid. A10 is A2. A11 is A9. A11 is A9. A12 is A8. Fine. A13 is write enable. Fine. A14 is RASN. Fine. A15 is A12. 15 is A12. 16 is A10. 16 is A10. 17 is A14. 17 is A14, yes. 18 is A4, valid. 19 is not here, so it's not connected. 20 is A13, fine. 21 is A5, fine. 22 is A3, fine. 23 is BA0. 23 is BA0, fine. 24 is not here. 25 BA2. 25 BA2, fine. 26 CASN, fine. 27 A15, fine. 28 A1, fine. 29 A11, fine. 30 is BA1, fine. And the last one is A6, fine. So this configuration now reflects our project, which leads me to an idea to save the project for future use. But this MX cube works so awfully. I can't change the path with this up one level because, yeah, I will show you. Yeah, here. Yeah, see, nothing. So I have to edit the path manually. And I will do this way. I will save it to our project file, a project folder, and the project folder is here, and I will copy its path name and enter it here. This should be our folder name. Yeah. Here is no file name field. So let's check DDR3L validation. Let's try save. Now let's check the file. No. Oh, there is something. DDR3 validation CA35, which is Cortex A35. So there is a file. But where it is? I can't see it. DDR3L validation. No, there is no such a folder. Okay. Yeah, I don't know. So, PCB, where to start? We have to work with the blue signals. Majority of them go to the, all of them go to the bottom half of the DDR3 module. And here on the MPU, every signal comes from the central area. So I will start with the top one. We will see. And now, as the node I got from some application node tells us that the blue ones will go from the will be routed on the inner two. And now the question is, should I go from this to here, or should I go from inside here? I think I can split, and I should split, because we obviously want. No, you know what? Now I want, and I really need to finish the interconnection here, because obviously it will affect our routing on inner two, because there will be some tracks, obviously. What can we do is to make some room, some space for the differential pair, because the differential pair is a big showstopper. Why? Because if I route this signals from here to here, I basically avoid the future routing of all other signals inside of this area, which is like too high price. So ideally, I would make the interconnection more vertical, like this, yeah, vertical, because I can still route the signals in between. So I have to delete what was already routed. Not the module. Nice. Is it even possible? Maybe yes. Yeah, something like this, but more. Or maybe I can move the interconnection above the memory module. Maybe here. I don't know. I really want to go with the pair like this. You can say it's not a big deal. Yeah, it isn't, but even the draft working must have some meaning, yeah. for instance here. We will see. Yeah, even here can be routed as a differential pair, but because it's a draft for routing, I won't overcomplicate this at all. Fine. So what happens is that we have some space here for, I don't know, 5-6 tracks. We can go around. I think it's a small win. Small, rather unimportant, but a win. Yeah, I think like this. I like it. Okay, so let's get back to the first blue signal, which is A7. A7 on the MPU, which I don't know how to continue with the signal swapping. I will just ideally with the top signal, I would go either here, like the most it's a big loop. It's not good. It's not good. So with this, I can go from inside. Yeah, like here. That can work, but we can't forget the cyan signal. The cyan signal is our LDQS, DQS0 signals, which is quite important. DQS is what? DQS is something that can't be. Oh, maybe it is. It can. No, DQS is a dedicated port, so must stay as is, where it is, where it is. So this pair can go. It can go through the area with no blue signals. Like here. What I've done is that I basically avoided routing from above downward, which is hey Ivan. Based on the comments, your comment is the second one from the beginning of the show, which is like 15 minutes ago. I'm routing alone, but yeah, we can route together. if you want. Okay, so this DQS0 pair DQS, the difference in length to clock signal can be plus minus 22, so very, very tolerant, extremely tolerant. Our clock signal is where? Clock signal is here. J7K7. J7 here. Ah, okay, wait. It's clock. Oh, it's clock. It's not DQS0. Okay. This is clock. Should I go like through here to here? I can. Will it help? Will it make any difference? I can't move the clock. It's a fixed pair, one of the fixed signals out of many fixed signals. Definitely, what should I do is to minimize the length of this bar that creates the barrier for the signals. So right now, at least, to help me thinking about that, is I will go with this pair closer here. Nice, like this. So yeah, we will see. So with this one, which is A7, yeah, sure. Thank you for being here. A7, based on our validator, A7. Wait, A7 is the signal that can't be. A7 is this one. Here. A7 ODT1. Really? A7 is not connected. A6 is not connected. Oh, why? Because we don't have these signals. We have only one module, so chip select 1 and ODT 1. We don't have second chip. This is for the dual chip configuration, so it's correct that these two signals are not connected, but why? Oh, it's not A7. Okay, I see. It's from A9 to A7. So A9 to A7, yes. It becomes too complicated for me. It's becoming too complicated for me. So this A7 signal should ideally go to A8 or A14. A14 would be nice. So let's make a quick check in the validator. So the A7, this is A7, which now it's like pointer to pointer. I'm losing track. A7 is connected to A9, but from A9 I want to go to A14 of the memory. So A9 to A14 in the MX, A9 to A14, and where the A14 is must be A7. Okay, we can do it. So A9 will swap with A14. It's valid. Yeah, here you can see it's valid. I am saving the project that never saves. But I really want to save it. Maybe because there is no such a folder. No, nothing. The MX Cube doesn't work on Mac. If I store it directly to the project folder, save. Nothing. Never mind. It doesn't work. It doesn't work. So A14, I need to update the PCB. Yes, A14. We are here. Now, the second one here. ODT, okay. ODT is one of the functional signals. ODT is A3, which comply with this, yes. It can't be remapped, so we need to fight with it. Where it goes? Here. it leads me to an idea that I should start with the signals that can't be remapped, because they will drive the entire area, that they will rule the area, because they will manage the routing. Okay. G17. G17 is here. A1 luckily not connected. A2, J17. J17. Unfortunately, I have to find it. J17. A4. Is it correct? No, J19. J19. J9. Why I said J17? J19. Here, chip select. Nice. It's awful, I know. It basically cancels any possible routing. Like yeah, like effectively. Now I have a trap. Here is a trap and nothing go from here to here. No, nothing. J19 is chip select. Chip select is L2. Yeah. Okay. What I'm doing now is, if these signals are fixed and can't be relocated to another pins, it's the latest released 10.05. I wanted to say that if I can't relocate these signals, I must use the layers that where these signals make the least harm, which I don't know is where, but no. J19, E17, ODT, E17, East 17, here, ODT. I already connected it. I don't know why. No, why, when. Clock, L2021, connected. Hopefully, not connected. And that's all. It didn't hurt. It did. It was not so painful. It wasn't so painful as I thought to be. We can fine-tune them a little. So it means what I've done was the signals, where the signals that can't be remapped, can't be. What I can see now is this signal. This clock signal should be protected, is highly sensitive, is crucial for the function, besides the other things. It must stay as it is. Maybe I can route it like in the horseshoe area, but or from here to here, like from here to here, from this side. I don't know. I will keep it. I will keep the clock, but what I have to check, have to solve is this. This is a showstopper. This signal. This one. So if I go here, At least I saved this area, which is crucial here. This is probably already lost because I can't go with the clock in between the tracks. The pads, or do I? Can I? Let's make a quick check. No. No. I can't. I can't go in between pads. So what I can is I can shorten this, the length of this, yeah, to be shorter or more vertical. We'll see. Let's continue with the signals that can be swept. So probably from the package, from here. This is the next one. So I will route it this way with the intention to connect it here to A8. So it means A13 to A8. A13. A13. So it means A13 is here. A20. Yes. And I wanted to connect it to the area, to the pad where the A8 is. So it means to swap A13 with A8. A13, A8. Yeah, it's pin swapping. A13 A8 and when the A8 was, will be, wait. No, here, 13 and 8. Yeah, here, A13, 8. Okay. So A13, A8, swap. It means A12 is A13. Yes. And it means A20 is A8. Yes. Save, update, yes. How to make it easier to do? How to save the project? Attempt number, I don't know. It's folder name. I don't know how to edit the file name. This doesn't work. No, nothing. It doesn't work. There is some French logic inside, which is no logic. I don't know. Yeah, it believes that there are two folders, but they are not. Okay. I hate tools that don't work. A9. The same strategy. Same strategy. A11 is the first empty, first available. So A9 to A11, A9 to A11. Can I swap A9 to A11? So A9, A11. So this will be 11, and when 11 is, will be 9. Okay, I can do. So A9, A11, swap, update PCB. Nice. Another one. A5. A5 to A6. Okay, can I swap A5 to A6? A5 and 6. So this swap. I can. Okay. 5, 6. So 5 and 6. Swap. Fine. Update. Nice. What else? A2. The nearest possible is A1. So A2, A1. It sounds like A2, A1. I can. A2, A1. 1 and or 2 and 1. Yes. Update. Nice. Another one. A3. I said A3 and my iPhone reacted because A3 sounds like Siri. A3. That's fine.
Siri.
A3. It's fun. A, address 3. A3 to A4. 3, 4. Sounds like not a big deal. Not a big deal. A3, 4. 3, 4. 4 and 3. I can. 3, 4. 3, 4. Swap. Update. Nice. Nice. Yeah, eventually I will need to make more space for this because about half of the signals, and I counted to 27, it means ideally 14 or 13 will go in this area, and the half of them from this, like the another direction, like, yeah, from the MPU to the right. So now we are at 6, so halfway, almost halfway. BA2. So BA2 should go to BA1. We'll see, validate. BA2, BA1. So BA2 and BA1. We can. That's a good message. BA2, BA1. Swap. Update. Lovely. What else? What else? A0. I'm too low. Here. A10. No, here. A15. Yes. So the question is, can be swapped A0 with A15? Let's check it. A0 and A15. Yes, it can. A0, A15. Here. Swap. Update. Lovely. Another one. Here. Another one is A10. So the question is, can be A3, can be address 3 swapped with A10? Let's check. A3 and A10. It can. Good. Address 3 and A10. Address 3, A10 here. Swap. Update. Close. Route. Be happy. What else? BA0. I think we reached the state where all the blue signals from the right area of the DDR3 module are connected. So now we are on a crossing. Not crossing. I don't know the word. Crossroads. Crossing, yeah. Fork. Turning. Fork. Maybe fork is a nice word. So, should I continue with this signal from here, or rather from the downward? You know what? It still looks like the DDR3 memory should be rotated to the left. Because if you imagine these long tracks can be shorter, and these long tracks above can be shorter as well if I rotate this to the left like this. Yeah. Maybe after the draft routing, because it will show us that it's possible to connect. Yeah, maybe when I will be done with the draft routing, I will delete all the tracks here and isolate this area from the MPU and rotate it. We'll see. Now back to this signal. Yeah, I think I should follow the idea that half of the signals should go from here to the upper, like through the upper half of the area, and half of them through the bottom area, bottom side, bottom half. Yeah. Now we have not 60. Again, we have 5, 10, 15, 20, 25, 27 plus 3 pairs. 27 plus 3 pairs. I don't know if these pairs are already connected or no. Should be. Yeah, this pair is connected. U17 is connected. U19 is already connected, and C20 is already connected. Okay, so 27, as I said, half of the 27 is 13, 14. So 14 signals ideally should go here through the upper half of the area. And now we are at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So ideally, 3, 4 more should go there. Wait, here is A12. I forget A12. Forgot. Yeah, that's complication F word. Okay. So BA1, A12. Okay. Sure. Thank you for watching. I appreciate it. How are you? BA1, A12. can I swap BA1, AA12? BA1, A12. I can. BA1, A12. Fine, update. Now, A15. Can A15 be swapped with BA1? A15, BA1. A15, BA1. It was here. No. Oh, I lost. I lost it. A15, BA1. A15, probably here. Yes. A8, BA1. A8, BA1, yes. And A15, A15, yes. Oh, I should start writing it down. Now, this one. Can be A10 swapped with A15, 10, 15. That sounds like another WD. A10, 15. 10, 15. It can. 10, 15. Swap, update. Nice. This one is BA0 to A10. Can BA0 be swapped with A10? BA0. It can. BA0. A10. BA0. A10. Swap, update. Nice. Okay, so one more. A5. Okay, not enough room for tracks. I didn't want to affect this area with the components because naturally there will be vias, and vias don't like drags. But yeah. Another swap. Is it? Okay, is it? Yeah, all the blue ones go here, not here. Fine. So another swap. Can A5 be swapped with A13? A13, A5. Where is A13? No, A5. Wait. I lost it again. A5, A13. Okay. Okay. Piece of paper and a pen and check. Oh shit. I was dealing. Okay. A8, BA1. Yes. A9, A14. Okay. A10, A1. Okay. A11, A11. Okay. 12, 13. 12. Here is 13. Okay. A13, VEN. Yes. 14, Russian. Yes. 15, BA0. Yes. 16, A3. Yes. 17, A7. Yes. 18, A15. Yes. 28, 8. Yes. 21, A6. Yes. 22, A4. Yes. 23, A10. Yes. 25, A12. Yes. 26, CSSN. Yes. 27, A0. Yes. 28, A2. Yes. 29, A9. Yes. 30, BA2. Yes. And 31, A5. Yes. Okay, it's consistent. I can't save this. So again, I will write it down. A5, A13. A13 is here and A5 is here. A13 and here. I can. Okay. 13 and 5. Swap. Yes. Update. Question. Can row access signal no, row access selection be swapped with A7. It can. Russian A7, swap, update. Fine. Let me take a mini break, a few seconds. I'm back in a, yeah, as I said, half a minute. I'm back. Let's check how many signals do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 or 3 more. And at the end, as I said, this memory module will be rotated. You will see that it will work perfectly. Yeah. So, can be CASN be swapped with A9? CASN with A9. It can. Okay. So CASN, not here. CASN A9. Yes. Update. No, F9 and 9. F8 die. Here. We are getting out of space here. And auto time as well. We have to get back to the future. Nice. What else? A0. Oh, here is no vent out. I don't know why. So, another swap can be A0 swapped with A5 A5 with A0. It can. Okay. A5, A0. 0, 5. Swap. Update. Nice. Can we push one more? I think we can. One more. No. Okay, I will make some space, some more space. One more. I think, yeah, the highlight mode would work better. Yes. So C, that's lovely. This signal doesn't need to be swept. There is one more signal without. Why? Why is it even possible? I found out all of them. All of them. Now it's the second signal that wasn't found out. Why? Why is that even possible? Okay, so 3 more swaps because I'm an idiot. Can VEN be swapped with A5? Yes. VEN A5. I've already swapped these two signals. VEN A2. Can VEN be swapped with A2? It can. VEN A2. VEN A2. Update. Okay. Can VEN be swapped with A3? It can. VEN A3. Update. Fine. Okay. I'm almost 2 hours in the show. How many signals do we have left? 1, 2, 3, 4, 5. Only 5? No. Here is another one without the, yeah. I spent like maybe more than a stream finding out all these F-word ink signals. And now there are only unfanned signals all the way. It's like, am I getting crazy? Maybe I do. Maybe I am. I think the best way is go through this area because these signals are already rather long, even with the rotation. And yeah, I mean that I need to extend the signals as much as possible because the length difference will be rather big. So yeah. It's a draft routing, but still I have to think. a little bit in advance. No swapping as well. It's a nice, pleasant surprise, but I don't know what happens. Maybe I solved by the swapping all the trouble signals, and now I'm flying freely. I think this one should be the one. Not. Maybe not. Yeah. Something like this. Now what? What happens? I'm changing the opacity of the. Oh, I see. I see. Okay. Okay. I wanted to emphasize the blue ones, but obviously. Okay. Here it will be Russian. Or not? I don't know if I count with the rotation. Maybe not. Yeah. All will be rotated. The entire thing will be rotated like. Yeah. 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 This is the trouble. Because if we don't have this clock signal here, oh wait. Yeah. Maybe I can drag. Yeah, the dragging doesn't work usually. One more in this area. Yes. Exactly. Yeah. This will make, this has made the future rotation, even with this draft routing, easier, because we want to go rather from the left side, not from the bottom side. I can't see more blue signals. Why is that? Am I blind? Where are the blue signals? It's already connected? I don't know. I don't believe. There are more signals like reset, but not in blue. Yeah, here is the reset. Okay. Okay, so it seems that this draft routing is done, is finished. And as you can see, obviously, how many time do I have? Oh, not much, 2 hours and 10 in the show. I'm saving this tool. I am making the screenshot of this thing, because I can save it because of some issues with the application, which I hate. So for the rotation, as we said, I can delete all these signals to make the rotation possible. These plus these. No, these. Which ones? Ideally these, because I need the water level ones. Now I can make some of them shorter. Yeah, there is a trick. If you want to bend a signal that can't be bent because there is nothing you can bend over, you always can break that track there is something bad with the DRC, I think. It will be solved later. Okay. And these ones. Okay, I can delete the ones, or maybe just this segment, these segments. Yes. Yes. And yes. Okay. So now I can select the entire DDR memory area, including all the tracks coming from the DDR3 module, and make this thing. Let me take a screen of it, because I will blog about it. I really do. I really will. Nice. So the rotation. Select, rotate. Yes. Wait, I need to delete these signals, these tracks, these segments. Yes. Mm-hmm. Yeah, it found the shorter way. Never mind. Mm-hmm. Yeah. I'm a little bit concerned with the signals. Yeah, I don't need to be. Don't need to be. It's exciting, isn't it? Nice. Okay. Okay. Yeah. I'm in the flow, so I will continue for a few minutes. It's like receiving, like getting a prize, a big prize after a fight. And this was a fight. And it will be, but one big battle has been won. Big battle. Important. Yeah, it's like the easiest routing because yeah, all the signals are already prepared for the easiest routing besides this. Okay. Yeah, this is a subject to change. something like this. Now, what else? Should be even. Yeah, one more trick here are, where is the pair? So here, yeah. Oh, one more. For now, I will connect it through here, but yeah, there is a chance to move the entire thing buff. No, one more. Yeah, maybe there will be more swapping here because the strategy is different. Maybe it isn't. If I go with this signal here, yeah, it will. No, I won't think about that today because I'm exhausted and I will finish these connections, conclude the session, and next week we will talk about the optimization because I think there is still a lot to optimize. Yes. So this is how I'm calling it draft routing looks like. Yeah. The positive is that both the magenta lines are about 25, 23, 25, 25 ballpark, and the red ones are 41, 40, yeah, 15 millimeters more. So we must optimize this horseshoe shape. Yeah, this will be our task for next week. So let's say reroute all these tracks. Yeah, all of these to hit the target length about 25. Or at least to not go around the entire module, because yeah, obviously we can see that, for instance, this signal goes all around the module here. Yeah, I will reroute all these, unroute all these first, then consider the sloping again. Is there a potential for that? Maybe it is, but I will need to solve these signals that can't be swapped, these two. And then we can go in between the pads. Yeah, something like this. Okay, it looks good. It looks much better than before. Much better. Okay. No more comments for today. Thank you. No more comments. It was a fruitful session today. I'm happy for that. A big battle was played and won. Thank you for being here. Thank you for watching. If you want to support me, fedevel.com. Do you want to show me? Okay. If you want, I will show you. If you want to support me, please consider enrolling or at least purchasing one of my courses. fedevel.com is a platform where the best electrical design courses are stored and purchased. I created two so far. I have created two. KiCad for beginners and KiCad for makers. KiCad for beginners is essentials in KiCad. You will design with me this power supply board. And in KiCad for makers, more complex, dual core MPU. Yeah, as you can see, USB Type-C, everything is there. What's special in these two courses is that there is a special promotion from nextpcb.com, which I thank you very much to them. If you enroll the course as a student, you will receive a coupon within 30 days, and then you can redeem your coupon at nextpcb.com, but not for the bare PCBs. It's the entire assembly, even including the components. Again, you will receive a coupon you can redeem at nextpcb.com, and the value of the coupon practically covers the price of the components plus the PCB plus the manufacturing cost of the beginner board and the maker board. So you can redeem, of course, for your projects. It doesn't need to be the project from the course, but the fact is that you will redeem, for instance, about $100 US dollar coupon for the KiCad maker board, and you can redeem it for your own assemblies. So if you consider that enrolling the course is $69 euros, which is like $75, you will receive $100 US dollar coupon, so voucher. So it's up to you. I think it's a no-brainer. Thank you for watching. Thank you for being here. DDR3L on the go. See you next week. Bye.